So what's up guys, Mr. Bella here with a quick video on distributive property. You're going to see another video soon. I'll probably link it also below, something like a little more intense, more with variables and stuff. But right now we're just going to get a little introduction to what the distributive property is. So let's check this out. So this is going to be like the starter. So yes, you could multiply 7 times 13. Will there be faster ways? I think some of you guys have seen the faster way, the shortcut of doing these kinds of multiplication problems using the distributive property, but maybe you just don't know you're using the distributive property. So one of the shortcuts would be 7 times 13. Maybe you don't want to do that whole thing, right? One way to look at 7 times 13 is it's also 7, so 13 can also be written as 10 plus 3. So if you do 7 times 10 plus 3 this way, you do 7 plus 13, but if you distribute, which you'll see soon enough, I can multiply 7 times just the 10, that's 70, 7 times just the 3, that's 21. So I add those two, and I would get 91. And that's the same as if you did it this way, 1, 2, 91. Is this faster? Yeah. But this way kind of helps when you're doing mental math. Do you have to do it this way? No, absolutely not. This is just another kind of way to show how the distributive property works. Let's think about the meaning of the word distribute. When you distribute something, you give something to each group. So like you're at a birthday party, cut the cake, you're gonna give a cake to each person that wants it. So you're distributing the cake. If you're dealing cards, you're the dealer, you're gonna distribute the cards to each person playing. Right? So that's what distributing means, and that's what it means mathematically. Okay, to show you guys, the distributive property is this. So if something's in parentheses and a number or variable is next to it, that means you multiply, right? Well, the distributive property says that you can multiply whatever's outside to whatever's inside once each time. So you can multiply a times b, and then add plus a times c. Same thing for the second example. A times b minus a times c. That's the same thing as if you subtracted or added things inside the parentheses and then multiplied. All right, so with order of operations, if you're looking at this, 3 times 4 plus 5. You could use order of operations and do 4 plus 5 is 9, so 3 times 9 is 27. Or you could go 3 times 4 plus 3 times 5. You get 12 plus 15 and you get 27. So it works. But why would you even need to use that? So if you have variables and you needed to simplify them, this is a way to get the variables outside of the parentheses. So here you have 3 times x plus 2. You can get rid of the parentheses by distributing. Distribute the 3 to the x and the 2. So 3 times x is 3x, plus 3 times 2 is just 6. And this is going to help later on when we're going to do more things with combining like terms. Let's talk about what like terms are. In an algebraic expression, like terms are terms that have the same variables raised to the same power, the same exponents. Constant terms are also like terms with each other, which makes sense because a constant term is like a regular number, like 5 and 7. You can add 5 and 7. You can't add 5 and x. If you had 5 plus x, you just leave it like that. There's no more simplifying, right? So in this case, like terms here are 5x and 2x, and 19 and 2. So the distributive property, you can combine these things, and you're going to use the other properties that we just learned about, the commutative property of addition, to show that you can switch these around. You can go, okay, this is the same thing as saying 5x plus 2x, and then plus 19 plus 2. You can switch them around. That's using the commutative property of addition. And these are like terms. These are x's. So this would be 7x, and 19 plus 2 would just be 21. Why are they like terms? Why is x like terms? So maybe think about like when you're ordering something from the restaurant. I've used this example before. If you're ordering something from the restaurant, and or maybe like your older brother's going, hey, what do you guys want? And he's going around the entire house. What do you want? And you know, your dad's saying, I want fries and a cheeseburger. Okay, and then your mom goes, no, I don't really want anything. I just want some like fries. Make that 2 fries. So she shares with her sister or something. And then you're like, I want a hamburger and fries or something, right? And he's like, oh, okay, I'm gonna get fries and another cheeseburger or something. So as you can see here, these mean food, right? But you just, in shorthand, you're writing letters. Well, those sure look like variables to me. Like terms are all the fries, right? So fries, 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 and fries. So it's not like when you go and you're gonna order all the fries and they're ordering it, you're gonna go, can I get fries? Can I get 2 fries? Can I get more fries? Like if you're the person taking the order, you're not gonna go tell the cook, can I get fries? And then 2 more fries, and then a fry, and another fries. Like, you're gonna want to combine those so you make enough for everyone. So let's see, all the fries plus 2 fries, that's 3, 4, 5. So that's 5 sets of fries. Those are like terms. That's why you can add them. You can't add the fries and cheeseburger. You can't. That's not a thing, right? You can put fries and cheeseburgers, whatever you want, but those are not like terms. You can't add them. There's a cheeseburger here. There's a cheeseburger here, here, and here. So those are 2 of them. So 2 cheeseburgers, and then one person, can't even remember who anymore, wanted a hamburger. So plus H. So if you are like the waiter taking the order, giving it to the cook, you're gonna say, okay, can I have 5 fries, 2 cheeseburgers, and a hamburger? That's much faster than saying this entire order here. Like, I'm not gonna lie, when I'm in the drive-thru, I take forever ordering and I say those things. But then once they put in the computer, once you're gonna tell the cook, you have to be really quick about it. And this is an example of why like terms work. Okay, and that's also why we can combine like terms with the distributive property. Yeah, so for example, if you had like 2 times, I want, fries, I'm not even gonna talk about fries. F plus 3, right? I'm gonna add 2 more to that. Whatever scenario you wanna put here, like how much fries cost. Like fries cost this much plus $3, you double that and you add 2 more dollars. You can't combine the 3 and the 2 because it's within the parentheses. And order of operations say you have to do the parentheses first. Well, you can't add F and 3. Those are, that's not like terms. You have a constant and you have a variable. What you can do though is you can go ahead and distribute. So this 2 next to it means it's multiplied. So you multiply 2 times F plus 2 times 3. Okay, so you can do that. So that's 2 times F plus 2 times 3. And then the plus 2 just stays there. It's just plus 2. So now let's see, let's simplify this a little more. 2 times F is just 2F. 2 times 3 is 6, and then plus 2. And then, look at that, you have like terms, the 6 and the 2. So this is 2F plus 8. And so that's simplified. So that's how you can get the variables outside of the parentheses. Okay, so let's take a look at this model over here. I'll show you this on Desmos later on as well. But look at this. This is a rectangle. How would you find the area of this rectangle? Right? Think to yourselves, what would you do? Because this is 5 and 3, and this is 6. So how would you find that? I think a lot of you guys are thinking, well, if I just do this, this is 8 times 6. I could just do 8 times 6. So yeah, how did you get 8 times 6? Well, you did 5 plus 3. So let's see, 5 plus 3, you multiply that by the width, which is 6. Okay, you can do that. And if I did that, I would get 6 times 8, which is 48. All right, 48 units squared, that's the area. What's the other way you can do that? Well, you can also take different parts of the rectangle. So you could have this rectangle and this rectangle, right? If I wanted to get just this rectangle, well, that would be 6 times 5, right? This would be 6 times 5. And this rectangle here, well, I would add to whatever 6 times 5 is. This is actually 6 times 3. To get this, this is 6 times 3. Let's see if that's, I mean, it should work. I mean, I just took the 2 areas. So 6 times 5 is 30, plus 6 times 3 is 18. You add that together, it's 48 units squared. So the exact same thing. Well, this is kind of an example of a proof of why the distributive property works. Because if I take this, okay, so if you look at that, you have 6 times the quantity 5 plus 3, and you also have this. Those say the exact same thing. Well, if I write it here, that shows the exact definition of the distributive property. 6 times 5 plus 3 is the same as 6 times 5 plus 6 times 3. I just distributed, right? I just distributed the 6 to the 5 and 6 to the 3, right? So that's another reason why the distributive property works. If you had a fraction like this, 1 times 2 3/4. Now I know you'd probably want to just multiply, change it to improper fraction and multiply, but there's another way. So 2 3/4, think about how else can you say 2 3/4? Well, it's 2 3/4, it's 2 3/4, right? So this is the same thing as 2 3/4. That's the same thing. 2 3/4, that's the same thing, right? So let's see, 1/2 times 2 3/4. That's the same as 2 3/4. Well, I can't write it like that, right? Because this way it's just saying I'm multiplying 1/2 times 2. So I'm going to put this in parentheses. And I'm going to use my rules of distributive property. I'm going to multiply 1/2 times 2 and 1/2 times 3/4. So 1/2 times 2 plus 1/2 times 3/4. Well, 1/2 times 2 is just 1. 1/2 times 3/4 is 3/8. And so that's just 1 3/8. Let's double check if this actually works, right? So 1/2 times, if I made this into an improper fraction, 2 times 4 is 8 plus 3 is 11 over 4. And I just multiply across. Multiply across, you get 11 over 8. Well, 11 over 8 is 1 3/8. Again, this was probably faster for a lot of you guys, but it just shows why the distributive property works and why, like, for certain problems, maybe this would make more sense. Like, maybe 2 3/4, that's easy to make into an improper fraction, right? If I did something like 1/2 times 102 and 5/8, right? That's a big number. If you're going to put that into an improper fraction, you're going to have to do 8 times 102 and add 5. That's big, right? So instead, I could just do this. I could do 1/2 times 102 plus 5/8, and that's a lot faster. I can take 1/2 of 102, which is 51, plus 1/2 of 5/8, which is 5/16. And so my answer is right there, 51 and 5/16. I don't have to do anything extra. And to close, I'm just gonna end with a couple of examples with variables here. So if you had like 3 times x plus 5 minus 1, let's say you had that. Or you had 7 times x plus y plus 7, like that. So you just have to distribute. I'm going to distribute here. 3 times x is going to be 3x. 3 times 5 is going to be 15. So I can skip that step. And then the minus 1. You don't multiply 3 times 1 because it's not inside the parentheses. And then you can just combine like terms. There's 3x plus 14. And then you're done because the 3x and the 14 are not like terms, so you can't add them together. There's 3 terms inside the parentheses. So I could just multiply everything inside. So 7 times x is 7x. 7 times y is just 7y. And 7 times 7 is just going to be 49. And then you double check there's no like terms in there. So then you're just done. So that was a distributive property. Hopefully that was helpful. And I will see you guys next time.